All right, ladies and gentlemen, today we are going to be moving on from area and into volume. So starting off in volume, we are going to be learning we're going to be learning about the prism and how to find the volume, lateral area, and total area of a prism. But before we do that, we got to get into a couple of vocab words. So first vocab word we're going to get into is the base. So the base is the two kind of like the top and bottom of these prisms. In formulas, it's denoted by the big B. Okay, and in in prisms, these bases are going to be like a shape, like a hexagon. It's going to be some kind of polygon for your bases. And this is knowing that base area is going to come in handy. So this B stands for base area. We're going to be using that in a little bit here. Okay, so that's the base. Now, next we have lateral edges. Lateral edges. So the lateral edges are a little bit confusing here. The difference between a lateral edge and a lateral face might be a little confusing to get at first. So a lateral edge is kind of like the corner here of your prism, okay? It's where the two sides of the prism meet together, okay? And next we have the lateral base. So lateral face is the side of the figure, okay? It's this big shaded area right here, okay? And the number of lateral faces a thing is going to have is going to depend on the sides of the base. So in this case, the side of the base has 1, 2, 3, 4, 5, 6 sides. So there are going to be 1, 2, 3, 4, 5, 6 lateral faces. Okay. Same thing with lateral edges. It's going to have the same amount of lateral edges as there are number of sides. Okay. And then lastly, we have the altitude. So the altitude, also known as the height, is the distance from the plane that goes through the base and the plane that goes through the top base. So the plane that goes through the bases. Now, just like before when we talked about triangles and area and all that, the height's got to be perpendicular to both of these bases. So if it is an oblique prism, oblique just means, kind of tilted. Okay, oblique prism means it's just a little bit tilted, a little off center. The altitude has to be perpendicular to the base. However, in a right prism, which means it's, standing straight up and down, notice here we don't have any height drawn. That's because in a right prism, your lateral edges are your heights. All these lateral edges are going to be perpendicular to the bases. But that's only in right prisms. Okay. So from this, we get a couple of different formulas. We're going to be asked for a couple of different things. So the first thing you might be asked for is the lateral area. That's what LA is. Okay, so the lateral area is just the area of all the lateral faces. Okay, so there's a couple ways to do this. If you, what you could do is you could find the area of one face, and then, if it's a right prism, actually, you could find the area of one face and then multiply it by the number of faces. Or likewise, all you need to do is just take the perimeter of the base and multiply it by the height or the altitude. Okay, so this P here is the perimeter of base. Okay, so you take the perimeter of the base, multiply it by the height, and that'll get you the lateral area. Okay, that's the area of all the faces. Then you have the total area. And what the total area is the area of all the faces around the sides and the top and bottom base area, which we said is B. So if you wanted to write it out using the things we had here, it's just PH plus 2B. All right. Some other people also like to write it like this: lateral area plus 2B. And that works as well. All right. Then lastly, we have the volume. So for the volume, all it is just going to be the area of the base. So the area of this bottom part times the height or the altitude. Okay, so there we go. We have lateral area, total area, and volume. Volume, we kind of didn't define this, but you guys have probably heard of volume before. Volume is just how much space this figure takes up. Okay, how much three-dimensional space. You think of it as how much stuff could we fill this prism with. That'll give you the volume. Okay, so we're going to take these three formulas and we're going to put them into action right down here. So we have this complicated shape here, and it's asking us to find the volume and the surface area. All right, so we'll start off with the volume. So the volume is just base times height. So all we need to do is find the area of this base and then multiply it by the height, which is going to be 3y. All right. Now, in this case, it's kind of hard to just figure it out like as is. So what I'm going to do is I'm going to break it up into a smaller, more manageable piece. I'm going to break it up like this. Okay, so I'm going to find the volume of this internal square. If I were to take that square all the way back. Actually, I'm just going to find the area of this square and then find the area of each of these sides and then multiply that by the height. And that should work out. So here, this square inside has a side length of 4x. So the base is going to be 4x times 4x. Plus, we have 4 of these extra segments right here. So I'm just going to do plus 4 times, and here it's just going to be x times 4x. So the area of the base is going to be equal to 4x squared, and that is this internal square right here, plus, and then we have 1, 2, 3, 4 of these, so 4 times, and then the base area here is just length times width, so x times 4x. And this will give me my base area. So my base area is going to be equal to 16x squared plus here, this is going to be 4x squared times 4, 16x squared, which is going to be 32x squared. Nice. Now we just got to take this and multiply it by the height. So in this case, it's going to be 3y. So the volume is equal to 32x squared times 3y, which is just, so it's going to be 96x squared y. And that is your volume. All right, next they ask for the surface area. Okay, so in a lot of these problems, it's going to ask for the surface area. The surface area is the same thing as the total area. So to find the total area, all we got to do is use the formula we had up here, which is just perimeter times height plus 2 times the base. So we already have the base, so we need to figure out the perimeter of this thing. All right, so total area is equal to, we don't know the perimeter just yet, so we'll leave that blank. We know the height is 3y, and we know our base is 32x squared, so it's going to be 2 times 32x squared. Okay, now the perimeter. So to find the perimeter, all I have to do is just add up all these x's here. So I'll start here. I got x, so that's 2x. So that's 6x, 7x, 8x, 12x, 13, 14x, 18x, 19, 20x, 24x. So our total area, if we multiply all this out, it's going to be 73. Wait, nope, 72. Plus 2 times 32, 64. X squared. There we go. That's our total area. All right. So that was finding. So it's very helpful when you're doing volume of complicated shapes like this to, again, break it down into its simpler parts, then use the volume formula and the total area formula. Okay, moving on. All right, so next we have a right prism has a height of x and bases that are equilateral triangles with side x. Show that the volume is that. All right, so all we got to do, start off here, is draw a picture. So you guys are going to have to forgive my drawings here. They're going to be pretty bad. So here we go. Draw a triangle, boom, boom, boom. Draw it down. Okay, that's a really bad drawing, but that'll work. So we have a right prism. It's on a height of x and bases that are equilateral triangles with sides of x. Okay, show that the volume is this. All right, so volume is equal to base times height. So if we know these bottom triangles, the bases are equilateral triangles, we actually have already learned a formula for equilateral triangles. It's really helpful. And that was x squared root 3 all over 4. Okay. So then, this is from a while back. Equilateral triangles, we discovered this in class. We discovered this formula in class. So all we got to do to find the volume is just take that base, x squared root 3 over 4, and multiply it by the height, which is x. So here when you multiply this, this x squared is going to be x to the power of 3, root 3 over 4. There we go. Now, if you didn't know how to do this, you could have drawn an altitude here, made it a right triangle. It's a 30, 60, 90 triangle. Figured out the height, multiply it by the base. You would end up with this equation. Then you take this, plug it in, and do what we did. But we already discovered that, so you didn't have to go through that whole process again. Great. Moving on. Okay. That's it. This is the last one. All right. So a prism has a volume of 100 centimeters and a length of 8 centimeters. If the cross section is an equilateral triangle, find the length of a side of the triangle. So the cross section here, let's draw it. So a prism has a volume of 100. So I'm going to write right here, volume is equal to 100. And the length of 8. Okay, we'll do that. The cross section is equilateral triangle. Find the length of the side of the triangle. Okay, so let's draw this prism. It's going to be the same thing as the prism I had above. It's an equilateral triangle again. All right, here we go. So it has a length of 8 and a volume of 100. So the cross section is an equilateral triangle. So what a cross section is it's just if we were to like slice this thing in half and we were to take both parts and look at them, like break it apart, look at the insides, that's what a cross section is. So basically what this cross section is telling us is what the base looks like. So it's saying the base is an equilateral triangle. So, and we are asked to find the length of the side of the triangle. So size X, we have a height of that. This shouldn't be that bad because we actually have, we just talked about if the base of an equilateral, or if the bases of these prisms are equilateral, then their formula is going to be x squared root 3 over 4. So we know what the volume is equal to. We know what the height is equal to. So all we have to do is plug it into the formula. So 100 is equal to our base, which is x squared root 3 over 4, times our height, which is 8. Now let's do some math. So we got 100 is equal to x squared root 3. 8 times 4 is going to give me 2, so I'm just going to do times 2 out here. Divide both sides by 2, so I get 50 is equal to x squared root 3. Going to divide both sides by root 3, I guess. Okay, so this is going to get a little ugly. I'm going to go over here. Actually, I'm going to go over here. So it's going to be 50 over root 3 x is equal to x squared. I'm going to simplify this. So it's going to be 50 root 3 over 3 is equal to x squared. And this is going to get really ugly here. So I'm going to square root both sides. So it's going to be, oh man, this is not good. So it's going to be square root 50 times root 3. So all that's under square root over root 3. Man. That's equal to x up top here. Square root of 50 can be broken down to 5 times 25. So it's going to be 5 root 2 root 3 over root 3. Yikes, this is getting ugly. We're just going to simplify this down into a fraction or into a decimal here just so that it's nice for us. So let's do that. So I'm going to take 2 times square root of 3 and square root it. So I'm just taking all that, I'm plugging it in a calculator. Oops. Okay, hold up a second. Plugging this in the calculator. Okay, divided by. Okay, so I got. Now I did this on my calculator on my phone, so I'm not 100% sure, but I got x is equal to 5.37. Let's check this. So the way that we check this is we take this, plug it back in for x squared here, or here, and see if we get 100. So I'm going to do that real quick. So 5.37 times 5.37277 times square root of 3 divided by 4 times 8 equals 100. Yeah, that's great. Nice job. Cool. So that is your correct answer. Nice. Great. So that's all the notes we have on volume for this week. Not a very big lesson. The biggest takeaways for you guys is to remember what all of these definitions mean and to remember what these different formulas are. Okay. Thank you all for listening, and I will see you in class.